In this episode, we're going to look at how to configure VLANs. I'll show you how to do it, and we'll talk about the concepts along the way. VLANs are helpful in the administration of logical groups, allowing members of a group to be easily moved, changed, or added. This activity that we're going to do, it focuses on creating and naming VLANs and then assigning access ports to specific VLANs. We'll be discussing how to verify the default VLAN configuration, configure VLANs, and then we'll look at assigning VLANs to ports. Greetings to all my tech heads out there in the KevTechify nation, and if you're new here, welcome. This episode is part of my series on configuration examples for the CCNA. I'm Kevin here at KevTechify. Let's get this adventure started. VLAN configuration. I have the Packet Tracer Lab open. On the left side is our work area where we see our topology, where we'll go and configure our devices. On the right side, I have the instructions. Bottom right is the normal Packet Tracer activity window that opens up that gives us our initial instructions. The top right is a Word document of those instructions. The Word document allows me to answer the questions, put my answers in there, and save the document. In my Word document, I can save those answers. We have our addressing table. These are how all the PCs are addressed, what VLAN they belong to. We have our objectives. We're going to verify the default VLAN configuration. We're going to configure some VLANs, and then we're going to assign VLANs to ports. Step 1, view the default VLAN configuration. Display the current VLANs. Now, on S1, issue the command that displays all VLANs configured. By default, all interfaces are assigned to VLAN 1. On switch 1, I'm going to go ahead and click switch 1, slide it over. I make the window once again a little bit bigger, going right to left. And enter, we need to get into privileged exec mode. Type in enable, hit enter. We are now in privileged exec mode. You can tell that because we are at the pound sign, hashtag, or my personal favorite, the waffle sign. From here, we can enter in show VLAN. It has the more symbol right here, signifying there is more information than just the 24 lines that were displayed. Go ahead and hit the space bar to display it all out. Now I can scroll up. By default, all interfaces are assigned to VLAN 1. That's what we see right here. We have VLAN 1, our default VLAN, and all of our interfaces are in there. Fast Ethernet 1 through 24 and Gig 1 and 2 are all in the default VLAN. Verify connectivity between PCs on the same network. Notice that each PC can ping the other PC that shares the same subnet. I'm going to go ahead and close this. As we look here, the subnets, the VLANs that are the same, PC1 is on 172.17.10 network. Same thing with PC4, 172.17.10. They're both on VLAN 10. PC2 and PC5, they are in VLAN 20, and their third octet is a 20. That signifies they're on their own network, their own VLAN. And then PC3 and 6 down here, third octet here is a 30, signifying we are in VLAN 30. Can PC1 ping PC4? I'm going to click on that, open up my command prompt, scroll up to my windows here. I'm on PC1. I'm going to ping PC4. Here's my IP address for my addressing table. Ping 172.17.10.24. That works. Minimize that window. PC2. Open up my command prompt. Ping PC2 to PC5. Here's PC5. Here's the IP address 172.17.20.25. 172.17.20.25. That works good. I'm going to minimize that. And then PC3, can we ping PC6 at that point? Here's the IP address for PC6, 172.17.30.26. Ping 172.17.30.26. We can see that we have successfully pinged that. Coming back down here, can they ping? Yes, they can. They can all ping each other. If you ping a host on a different network, we'll see that it fails. I clicked on PC1. I'm going to go ahead and ping PC2 right away. Ping 172.17.20.22. That's the IP address for PC2. And notice we are on different VLANs. PC1 is VLAN 10. PC2 is VLAN 20. They are not communicating. I guess it could be doing an ARP lookup. But we got failed 3 times. Usually when you fail 3, especially if you fail 4, that means we're just not going to reach it at that point in time. Coming back to our instructions, ping other hosts on the networks, they fail. Now, what is the benefits of using VLANs? Now, there's several benefits here of using VLANs. The primary benefits of using VLANs are, first one here that we usually talk about is security. We have security because we can put these devices, we can group them up, and other devices can't necessarily talk with it. HR, you have a lot of personal information in there. You don't want everybody to have access to that, so you put them in their own VLAN. That is an example of security. Another primary reason or benefit here is cost reduction. Because we have these multiple LANs, if we did it not virtually but physically, for every LAN you got LAN 10, LAN 20, LAN 30, you would need to have a set of another switches. You would have 3 switches for LAN 10, you'd have 3 switches for LAN 20, you'd have 3 switches for LAN 30. You'd have a lot more expense on just hardware alone. And so that's where we get our cost reduction from. Another primary benefit is higher performance. We get higher performance by using VLAN because we separate that traffic. We separate that traffic, we minimize the amount of traffic that goes across it, across those connections. Only the device that needs to communicate with each other, you put those in a VLAN. And then other devices don't hear all of that traffic. Another primary benefit is broadcast storm mitigation. Broadcasts are limited on a VLAN or on a LAN. That broadcast stays on all the devices on the VLAN. When we create a VLAN and we put part of our devices in there, that broadcast will stay in just that VLAN. It won't go to any other VLAN. And there can be situations on a network where we start what we call a broadcast storm, where one broadcast starts another broadcast, and then that triggers another one, and pretty soon we have all these broadcasts happening on the network, and it brings our network down to a slow halt because we have no bandwidth available to do anything productive. Having these smaller virtual LANs, that gives us a smaller footprint to have these broadcast storms start. Another primary benefit here is improved IT staff efficiency. What we're talking about here is, because we only have one set of equipment instead of 3 sets of equipment, you only have to go and configure one device. You only have to go and troubleshoot one set of equipment. If we had 3 LANs and 3 sets of switches, you'd have to go through and troubleshoot that and copy the configurations around. Now you just connect into one set of equipment, you're good to go for all of your VLANs. Another primary benefit that we talk about is, and the final one here, is we're looking at simpler project and application management. Simpler project and application management. Because we have less equipment to manage, we have less to purchase, less to maintain maintenance agreements on, less to do maintenance on backups and rolling out new equipment. It allows us to do project management better, application management better. I hope you're liking this episode on practical configuration examples. Leave a comment on what you think about these configuration examples. If you still have a question or comment, please let me know below. You can also visit my website at KevTechify.com for all of my details and how to get these episodes in video and podcast form. On to part 2, configure the VLANs. Create and name VLAN. Once again, you have to create the VLAN and name the VLAN before you actually get in and use it and assign ports. Create the VLANs. Names are case sensitive. We are on switch 1 again. And here was our show VLAN. As we can see, we have just the 5 default ones. We have the VLAN 1 is the default. 1002 is some FIDI, that's fiber. 1003 is token ring, that's an old technology. 1004 is another fiber optic one. And 1005 is another legacy one. So we have 5 of them there. You can't do anything with these defaults. You can't delete them. You can't rename them. You just accept that they're there. And as a reminder, in a production environment, you want to not use VLAN 1 as your default VLAN, as your native VLAN. You want to use something else there. But this is the default starting point where you don't have any configurations. Everything is in VLAN 1. Let's go ahead and create our VLANs. Here, we need to get into global configuration mode. We enter in VLAN, then the number. And then once we're in there, we can name our devices. Get into global configuration mode. We type in config T. We are there. Now let's go ahead and create our VLAN. It's VLAN and then the number of it, VLAN 10. And we're going to name it. And these names are case sensitive and punctuation sensitive to get credit inside a packet tracer. Name space and then capital F ACULTY / capital STAFF. There's the name of it. And now we have to create the remaining 4 VLANs. You could type exit and then type VLAN again, but you don't have to type the exit. You could just type in VLAN 20, changes you to VLAN 20, and you can name it. So name space students. Once again, you gotta make sure you spell it right and have your capitalization and punctuation correct. Go to VLAN 30. Let's create that. Let's name VLAN 30 guest parentheses default parentheses. Let's create VLAN 150 and name it voice, all in capital letters. We created that. Verify the VLAN configuration. Which command will only display the VLAN name, status, and associated ports on a switch. Well, it's a show command, but we need to get into privilege exec mode. We're in VLAN configuration mode. We type in exit once, type in exit twice to get out of global configuration mode. We are now in privilege exec mode. I hit enter to give me a couple clear lines. And we're looking for the command that'll show us the VLAN name, the status, and the associated ports. And that's it. That command is show VLAN and then brief. Show VLAN brief. And that's where we have our information. We have the VLAN, we have the name of it, we have the status, and what ports are assigned. Right now, we can see that all the ports are still in the default VLAN, but here is our ports are created. 10 the faculty staff, 20 the students, 30 the guest default network, and 150 is our voice. Let's go ahead and answer the question. The command here is, well, you put your device name. I like to put what mode I'm in. So I put down switch or router. Here we're working on a switch. Then we put down the waffle sign. And then once again, that command was show VLAN brief. Next step, create the VLANs on switch 2 and switch 3. Use the same commands from step 1 to create and name the same VLANs on switch 2 and 3. Okay, seems simple enough. Let's go to switch 2. Log in there. Get into privileged exec mode by typing enable. Global configuration mode by typing config T. Then we create the VLAN by VLAN space and then the number. Now we can name it, and this was faculty/staff. Create VLAN 20. We can name it students with a capital S. We can get into VLAN 30. We create it, then we can name it. And this was guest parentheses default closing parentheses. Let's create VLAN 150 and name it voice in all capital letters. Type out exit twice to get us to privileged exec mode, and then show VLAN brief just to confirm that we do have our 4 VLANs here. 10, 20, 30, and 150, faculty, staff, students, guest, and voice. Now we can go and configure S3. Click on S3, bring it up, make it a little bit wider, going left to right. Enter in, enable global configuration mode by config T. Now we can create the VLAN, so VLAN 10, we can name it faculty/staff. Create VLAN 20, name it students. Create VLAN 30, name that one. Guest default, and let's create VLAN 150 and name it voice, all capital letters. As I look back, I see that I skipped VLAN 99. I need to go and create VLAN 99 on all 3 of those switches. We'll go ahead and start with S1 because I like to do it in order. Get into global configuration mode, create VLAN 99, and then name it management and native, no spaces in there. There we go. Exit out, show VLAN brief. We now have that in there. Go ahead and minimize that. I gotta go to switch 2, create that one. Config T, VLAN 99. I don't know, somehow I missed it. Name management and native with no spaces in there. Exit out, show VLAN brief. There, it's added in. Minimize the S2 window. Let's open up S3 quickly. Create VLAN 150 and name it management and default. Oh, no, that was the wrong one. I got to create VLAN 99. Now, I went and I just renamed a VLAN. What you can do is just type in that command again, it overwrites it. VLAN 150 was our voice, right? Let's create VLAN 99 and let's name it management and default. Oh, it's not management and default. It is management and native. There we go. Exit out, show VLAN brief, and there is our VLAN 99. That takes care of steps 1 and 2 and 3, and we verified our VLAN configuration. On to part 3. We created our VLANs, now we're going to assign VLANs to ports. Assign VLANs to the active ports on S2. I'm going to go ahead and click on S2. Brings it up. Configure the interfaces as access ports and assign the VLANs as follows. VLAN 10 to Fast Ethernet 011. First thing we need to do is get into global configuration mode, config T. Now we go into the interface, so interface F011. We change this, we make it into an access port first. That is switch port mode access. We get that. And then once we know it's an access port, we then go and assign it to the VLAN. And that's another switch port command. So switch port access, because it's an access port, we need to specify that. VLAN, and then what VLAN number it is VLAN 10. Assign the remaining ports to the appropriate VLANs. We could scroll up here and look at our addressing table. We have PC2 in VLAN 20, PC3 in VLAN 30, or you can look at our configuration, our topology right here, snuck in behind the S2 window. I'm going to scroll down to my commands. Actually, I'm going to leave my addressing window up here because I can see my commands right here. And what I'm going to do is PC2 we look over here. I clicked in the window, I moused over. PC2 is in F18. So port 18 needs to be in VLAN 20. Let's go into port F0/18. Change that to an access port. So switch port mode access. Then we have to assign it to the VLAN. Switch port access VLAN 20. I spell switch port correctly. And then the last one we have to do is right here. PC3 goes into F06. PC3 is on VLAN 30, so we need to take F06 into VLAN 30. Change to interface F0/6. F0, that's slit. Make sure that is a access port, so switch port mode access. Once it's an access port, then we assign it to a VLAN, switch port access, and then we want to say VLAN is our keyword, and then what VLAN are we assigning it to? We are assigning it to VLAN 30. We have that done. If we exit out, do a show VLAN brief. Oh, we got to exit all the way out to privilege exec mode. Show VLAN brief. We can now see that VLAN 10, the faculty and staff VLAN, has port 11 in it. We see that VLAN 20 has Fast Ethernet 18 in it. Get rid of I screwed those up. And then VLAN 30 has Fast Ethernet 06 in there. That's what our topology shows us. Go ahead and minimize that. Let's scroll down to where we're at. Assign VLANs to the active ports on switch 3. Right here is the information we're going to use. We'll use those same commands from up here. I'm going to go ahead and click on switch 3. Get into global configuration mode, config T. Now we can go into the interface of Fast Ethernet 11 right here. So F space 0/11 interface F 0/11. There we go. Now we need to make sure that this is an access port, switch port mode access. Spell access correctly. Now, once it's an access port, we need to assign it to a VLAN. So switch port access VLAN, and then this was going into 10. Spell VLAN correctly. There we go. Now we can just go ahead and change the interface. Next interface was 18. So interface F0/18. Switch port mode access to turn it into an access port. Then we have to assign that port to a VLAN. Switch port access, because we're dealing with an access port, VLAN, and then that goes into VLAN 20. Let's go ahead and change to the final Ethernet port of 6. So interface F0/6. Change that into a access port. So switch port mode access. And then assign that port to the VLAN. Switch port access VLAN, and that was VLAN 30. Exit out once, exit out twice to global configuration mode. Show VLAN brief. We can confirm that VLAN 1 or VLAN 10 has Fast Ethernet 01 in it. Oh, must not have typed 11, must have typed 10. So I have to go in and change Fast Ethernet 01 and 011. 01 I have to move back to the default VLAN, and then Fast 11, Fast Ethernet 11, I have to bring down the VLAN 10. Let's go ahead and make that change. Now, in order to remove it from a VLAN, we have to go into the interface. Got to hit global configuration mode first. Then we can go into the interface, and once again, we need to take out Fast Ethernet 01. We need to remove it from VLAN 10 and put it into VLAN 1. We can just do a simple switch port access VLAN 10, or sorry, VLAN 1. That moves it in there. Now we can switch to Fast Ethernet 0/11. That's the correct one we have to do. First thing we have to do is turn that into an access port. So switch port mode access, and then we need to assign it to a VLAN. Switch port access VLAN, and that is supposed to be VLAN 10. Exit out twice to privileged exec mode. Show VLAN brief. Coming back here, VLAN 10 now has port 11 in it. That's what our instructions tell us right here. VLAN 20 has port 18 in it. Our instructions tell us that here. And our guest network, VLAN 30, has Fast Ethernet 06 in it. There we go. Step 3, assign the voice VLAN to Fast Ethernet 03 on switch 3. As shown in the topology, I'm going to go ahead and minimize it. Fast Ethernet 011 connects to a Cisco IP phone, and that's where we can assign a data VLAN and a voice VLAN to this port, to Fast Ethernet 11, and that's what we're going to wind up doing here. The IP phone contains an integrated 3-port switch. One port of the phone is labeled switch. That connects into our switch to S3 here. Another port connects Another port on the phone is labeled PC. That's where you connect your PC into it. And then the phone itself has that third port. It's internal. You don't actually see a physical port because it's just hardwired into the phone itself. That connects into the phone. This allows you to have one wire and two IP devices there. You only have to run one wire across 3 rooms to that one cubicle to connect in your phone and your PC. Switch S3 interface must be configured to support user traffic from PC4 using VLAN 10 and voice traffic to the IP phone using VLAN 150. The interface must also support quality of service and trust the class of service, that's layer 2, values assigned by the IP phone. IP voice traffic requires a minimum amount of throughput to support acceptable quality. This command helps the switch port to provide minimum amount of throughput. I'm going to go ahead and click on switch 3, take us into that. Now notice we have to go back into Fast Ethernet 11 here. We already set up our data access VLANs. That came up here. We assigned it there. That's the data portion. Now we need to assign the voice portion. First thing we have to do is get into the port. Then we have to set up our quality of service. That is this command right here. Once we do that, we also have to specify we now have a voice VLAN and what number that is. Okay, back in switch 3, get into global configuration mode by typing config T, get into interface F0/11. Now we have to enter in the command MLS QoS for quality of service, trust our COS, our cost of service. And then we have to tell to put not only that we have an access port for data, we now have a VLAN for voice. And that's another switch port command. And instead of putting access here, we put the word voice because we're dealing with the voice part of this connection. And then what VLAN is it? It is VLAN 150. Go ahead and hit enter there. Exit out. Exit out. Show VLAN brief. And now we have VLAN 10. We have Fast Ethernet 11. And then for our voice, we now have Fast Ethernet 11 also. It can be listed twice as long as the second one is our voice VLAN. Verify loss of connectivity. Previously, PCs that shared the same network could ping each other successfully. Study the output from the following command on S2. That means we need to look at this information right here. Answer the following question based on your knowledge of communication between VLANs. Pay close attention to the gig01 port assignment. The gig01 port here is configured in the default VLAN. Try pinging between PC1 and PC4. I'm going to go ahead and minimize this. Click on PC1. And I'm trying to go to PC4. That's a ping command. So ping. Right here is our IP address for PC4, 172.17.10.24. 172.17.10.24. Failed once. Could be doing an ARP request. Maybe. Failed twice. I don't know. Looks like it might fail. Failed 3 times. Probably going to fail a 4th. We have failed 4 times. We are not successfully pinging. PC1 is not connecting, not pinging PC4 at all. Although the access ports are assigned to the appropriate VLANs, were the pings successful? No, they weren't. Now, why weren't they successful? Port 18 was assigned to VLAN 10. Port 11 was assigned to VLAN 10. They should be able to ping. Now that we've implemented these VLANs, earlier, back before we created our VLANs and put ports into VLANs, PC1 was able to ping PC4. What that means here is all through this path from PC1 to PC4, this was all VLAN 10. It was all VLAN 10. It works successfully. PC1 is communicating with PC4. Looking at how the traffic goes through, it goes from PC1 to switch 2 to switch 1 to switch 3 to the IP phone to PC4. We have now put PC1 and that connection to switch 2 into VLAN 10. We have put PC4 phone 1 into VLAN 10, VLAN 150 into switch 3. If we look at the output shown here from our show VLAN brief, we can see here that the connection between S2 and S1, that's gig 01 on switch 2, gig 01 right here is in VLAN 1. We are sending traffic from PC1 into switch 2, and then we're trying to go across an access port here that is set up for VLAN 1. Different VLANs, they don't work together. And the answer here is no, it didn't work because the pings failed the ports between the switches are in VLAN 1. That's the default VLAN. If we look, that's what we see right here. Gig 01 is in the default VLAN, VLAN 1. And PC1 and PC4 are in VLAN 10. Once again, you can't cross VLANs with traffic. They are separate logical networks. What could you do to resolve this problem? Well, in order to get this VLAN worth of information to go across there, and then VLAN 20 and VLAN 30, we have to change the connection between switch 2 and switch 1 and switch 1 and switch 3 to a connection type that supports multiple VLANs of information. And that connection is a trunk. And so what could we do to resolve this problem? Configure the ports between the switches as trunks, and that would take care of our problem. That was Packet Tracer Lab 3.3.12 VLAN configuration. It was my pleasure to provide you with this wonderful episode on configuration examples. If you like this episode and you got value out of it, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All my socials and contact information are on my website, KevTechify.com. There you can find out how to get all these episodes in video and podcast form. Thank you so much for watching this episode of my series on practical configuration examples for the CCNA. I've created 4 wonderful playlists for you on the CCNA. These episodes, I go through all the concepts that Cisco calls out for the CCNA. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.